Well, hello guys, here Mr. G with another video. This time we're going to be working for the grade 11, however it is applicable for the grade 10. This question was question 2 from November 2022 and it's related to bonding as well as Lewis dot diagram. I'm going to leave the question in the description below so you can answer before watching the video. And before we answer the question, don't forget to subscribe for the channel and like the video. This question says consider the following compounds, and you have 3 compounds: O2, H2O and H3O plus. Question 2.1, define the term molecule. And all we have to say here that a molecule is a group of 2 or more covalently bonded atoms that function as a unit. There is 2 marks for that one, and as I said, it is applicable for both grade 10 as well as grade 11. Draw the Lewis dot diagram for O2 as well as for H2O. So let's do the O2 here on top. On this bottom here, I'm going to do 2.2.2 now. What we need to know? We need to know that in the Lewis dot diagram, we always or only going to represent the valence electrons. So for this one, you have to go to the periodic table. Now, the periodic table, guys, in terms of valence electron, you are going to use this valence, these group numbers using the Roman numbers. For instance, oxygen here will have 6 valence electrons. So this one, all those elements down a group 16 have 6 valence electrons, including oxygen, which is the question. All this one will have 6 valence electrons. That is important because for Lewis dot diagram, we need to use that one there. So oxygen have 6 valence electrons. If we go to hydrogen here, which is the next one, we need hydrogen. All these elements in group 1 will have, using the Roman number, will have 1 valence electrons. All right, that is important to know. So coming back to oxygen, we have oxygen which have a 6 valence electron. How are we going to represent those 6 valence electrons? We're going to draw dots to represent electrons around oxygen. But guys, this will be like if there were size around the oxygen, like in 4 sides. You cannot just draw dots there around. It will be like in a size here, so in which in each of the sizes you can actually represent only 2 electrons. So let's do the following. We are going to represent 6 electrons, and using dots we're going to do this one, 2, 3 and 4, and then we are going to repeat 1, 2, 3, 4, 5 and 6. There we go. That is the Lewis dot diagram for oxygen, but we do not keep that square line there, so we're taking it off. That is the Lewis dot diagram for oxygen. Remember, it is in pair of 2 and you start only with 1. I'm going to make it a little bit closer because they are too far, so I'm going to do it. I show you how it's done. So I'm going to say 1, 2, 3 and 4, then I'm going to 5 and 6. So we can see that we have a pair of 2 electrons, but we have 2 unpaired electrons. And what I want you to note, I want you to note that these 2 electrons here are going to be called lone electrons. This is lone pair. Lone pair. It is important to know that this one here is called lone pair. And the other ones that are single, in other words, this one here is going to be called unpaired electrons. Unpaired, let's fix that word real fast. Unpaired electrons. And these unpaired electrons are the one that is going to be involved in the bonding. So you have 2 oxygens in the same situation. So let's draw the other oxygen, and I'm going to do the Lewis dot diagram. You already know how it is done. So there will be now 1, 2, 3, 4, 5 and 6. Once more, this one have 2 unpaired electrons. So what is happening? Each of them need to be with a full number of electrons in the electron configuration. So they are going to share those unpaired electrons. So how is this going to happen? We are going to write it on this side there, on that side there, and there. We have 1 oxygen which have the 6 valence electron, but the 6 valence electrons are going to be in such a way that the 2 unpaired electron will be together. So we are going to have, for example, here is going to be a lone pair as well as here, but the 2 unpaired electrons will come together here so they can share with the other oxygen. So the other oxygen will still have the 2 lone pair, and then here is going to be the other 2 unpaired electrons. This one here is the bonding. That there is what we call the covalent bonding. This one is a double covalent bond. Alright, I hope you understand. This is the Lewis dot diagram for the O2. That is for O2. Let's go to do for H2O now here at the bottom. Now we're going to answer here 2.2.2. For H2O we have oxygen. We already know how it looks like. Oxygen, it is 1O with the 6 valence electron, which we can start from any side. I'm going to write 1, 2, 3, 4, 5 and 6. Remember, it's 2 by 2. So let's quickly take these two here and remove it a little bit more to that side so they look more accurate. There we go. So now what is going to happen? We have 2 hydrogen. Hydrogen have only 1 valence electron. Remember that one? So hydrogen, you have 1 hydrogen with 1 valence electron, which means it's 1 hydrogen with 1 dot, and the second hydrogen with another dot. What is going to happen? Oxygen needs 2 or has 2 that can share, and hydrogen has 1. So oxygen is going to share those 2 with hydrogen. But note, they are not going to be moving. In other words, oxygen will keep the lone pair as they are, like this. This is the lone pair of oxygen, as it is there. I copy exactly as it is there. Here is the unpair, and they will be sharing with 1 hydrogen. There is 1 hydrogen here. Alright? And here is the other unpaired electron with the other hydrogen. So here is the other hydrogen, guys, and this one is the Lewis dot diagram for water. Alright, now instead of the dot, you can instead draw a line. So this one you don't need, and you draw a line for a single bonded, and here if you want you can draw a line for a single bonded. This one is the Lewis dot diagram for water. Note the following: you don't have to do a line, you can keep it with points. Now if you do that, you will get 2 marks. So the marks, actually you will get here 2 marks for this representation, which must be exactly like that, and 2 marks for water, and that's it. Okay, now question 2.3. The H3O plus ion form when the oxygen atom in H2O donate its lone pair of electrons into the vacant orbital of H plus. Write down the name of the type of bond described by the underlined phrase. That one is quite simple. The name of that one is dative covalent bond. That is a dative covalent bond. So if you say that, then you will get 1 mark. Now question 2.3.2, draw the Lewis structure for the H3O plus minus. Now what is happening? What did happen here? Water gain a proton. Water will gain a proton. Now what is a proton? Proton is an H plus, and H plus do not have any electron. It already gave away that electron. So this one that does not have electrons to share is going to come here, and because it does not have electrons to share, it will share with both of these lone pair. So there will be a hydrogen, and because this one is a H plus, everything now will become positive because it gained a proton. This one, guys, is the Lewis structure for the H3O plus ion. I hope you understand. It's quite simple, and it's for sure going to be in the exam somewhere. Question 2.4, which molecule is polar, H2O or O2, and explain your answer. Now the answer here is H2O, but let's quickly explain that one here. So let's use here the same water molecule we are talking about here. Now when you go to the electronegativity, which is given to you in the periodic table, you can see the electronegativity is the numbers here on this side. So for oxygen is 3,5 and for hydrogen is 2,1. In other words, oxygen have a greater electronegativity than hydrogen. The greater the electronegativity, the stronger the atom is going to pull the bonding pair. Therefore, oxygen, because it's pulling this bond here stronger towards itself, will become slightly more negative than hydrogen, because it will have more hydrogen towards the side there. So if let's for instance do a molecule like this here, more or less this will be a water molecule, more or less, okay? All this side here will be slightly more negative than the other side, and all this side here will be slightly positive. It doesn't mean that this actually positive is slightly more positive than the oxygen, because it have less electron around. All the electrons will be pulled towards the oxygen because of the electronegativity. If this molecule can be divided in two, for instance in this divided there, you can have one side that is a positive side and one side that is negative side, and therefore the molecule is a polar molecule. Now, what will be the best explanation to give? All you have to say is that the molecule is asymmetrical. And that will give you the mark here. That's all you have to say, okay? So, in this case, is 1 mark for saying that the answer is H2O, and 1 for saying that because the molecule is asymmetrical. But the explanation, guys, is in this point of the molecule with the electronegativity. And this is all for this video. I hope it helped. It's a very good question to practice and learn the topic and recall the topic. Next time we're going to be working with this question here related to intermolecular forces and physical property. Very good question. Don't miss that video, but please don't forget to subscribe for the channel, a thumb up. I'll see you next time. Mr. G here.